we're going to deal with product rule. So in the beginning of every lesson, we are going to derive a formula or a proof or give theory behind that particular topic. So in this video, we are going to deal with product rule. I'm going to derive the product rule. Most of you know that the product rule says if you have a function k of x, which is equals to f of x times g of x, then the first derivative for this function will be equals to f of x times g prime of x plus. Now we keep g of x to be fixed, then we derivate f of x. So we're gonna say this is g of x times f prime of x. So this is the product rule, but we are going to derive it using the first principle. So now we need to let's let k of x be a function which is equals to g of x times f of x. So using the first principle, this is equals to k prime of x will be equals to the limit as h approaches 0 of g of x plus h times f of x plus h minus g of x times f of x divided by h. So now we need to proceed. So here we are going to add 0. I will show you how we are going to add 0. So this is equals to g of x plus h times f of x plus h minus, this is our 0, g of x plus h times f of x minus, positive g of x plus h times f of x. When we add these two terms which are here, we'll get that this is 0. So let me just increase space for this proof. Then we minus by g of x times f of x. Then we divide by h. So now it's time for us to rearrange. So we are going to put limit and we'll take out a common factor. So between these two terms which are here, between this one and this one, we see the common factor to be g of x plus h. Then the common factor will be f of x plus h minus f of x divided by h. So let me just take the limit. Then now, between these two terms which are here, between this one and this one, the common factor appears to be f of x. So I'm going to take the common factor f of x. So we'll have f of x into g of x g of x plus h minus g of x divided by h. So when you distribute this limit, we'll have that the limit as h approaches 0 of g of x plus h times the limit as h approaches 0 of f of x plus h minus f of x divided by h minus the limit as h approaches 0 of f of x times the limit as h approaches 0 of g of x plus h minus g of x divided by h. So let me reduce this. So now, what you can see here is that when you substitute h, we'll have g of x times this whole thing which is here in the first principle. It is the first derivative of the function of f. So this one will become f prime of x. So here there is an error a little bit. So here this one will become positive. So here we're going to take out the common factor f of x into the positive g of x. Then we divide f of x from minus g of x divided by f of x. Then it will become minus. So this one will be plus. The limit as h approaches 0 of f of x will be f of x. So this one will be the first derivative for g. So we'll have g prime of x. So now, the product rule is proven. So we can deduce that k of x, which is equals to g of x times f of x. When you take the first derivative, k prime of x is equals to g of x times f of x, f prime of x, plus f of x times g prime of x. So this one is the product rule. So in the next session, we're going to deal with exercises to see if we really get this formula. So put it in mind. And they might ask you even in the exam or even in the test. So in this chapter, we're going to deal with some questions, or we're going to have a tutorial that is involving the derivative by product rule. Suppose you are given a function y, which is equals to 3 minus x squared times x cubed minus x plus 1. By expanding, you can take the derivative of this but it might take time. So it's better if you use the product rule. So here you're going to use the letting method. Product rule says if you have a function, let's say the function is k of x, which is multiplying maybe g of x times f of x. The first derivative for this function would be it should be g of x times f of x, f prime of x plus g of x times g prime of x times f of x. So even here we can say that let this function, which is here, to be equals to y, which is equals to k of x. So it's obvious that since we have k of x to be equals to y, that will mean that even g of x will be equals to 3 minus x squared, and f of x will be equals to x cubed minus x and plus 1. So now the product rule says what? Product rule says that k prime of x is equals to g of x times f prime of x plus g prime of x times f of x. So here we already have g of x and we already have f of x. So now let's compute, or let's do g prime of x, or we'll do f of x, it's up to us. So g prime of x will be equals to the derivative of a constant is 0, and the derivative of minus x squared is minus 2x. So let's do f prime of x. The derivative of x cubed is equals to 3x squared, and the derivative of minus x is equals to minus 1. The derivative of 1 is 0. So now we have f prime of x and g prime of x. So now y prime, which is equals to k prime of x, is equals to, what is g of x? G of x is 3x, is 3 minus x squared. So I'm gonna say 3 minus x squared times f prime of x is equals to 3 minus, 3 x squared minus 1 plus g prime of x is minus 2x, and f of x is equals to x cubed minus x plus 1. So it's x cubed minus x plus 1. So this is the first derivative for this function. If you want, you can simplify. Or if you don't mind, we can simplify. So k prime of x is equals to this times this. So we're going to use FOIL method. So we're going to have 3 times 3 is 9x squared and 3 times -1 is minus -3, minus x squared times 3x squared is equals to minus 3 x to the 4th power, and minus x squared times -1 is positive x squared. So minus 2x times x cubed is equals to minus 2x to the 4th power, and minus 2x times -x is positive 2x squared. Then minus 2x times plus 1 is minus 2x. Then now let's collect the like terms. 9x squared plus x squared plus 2x squared is equals to 12x squared. And we have minus 3x to the 4th power minus 2x to the 4th power. Then we'll have minus 5x to the 4th power. Then the one with, we don't have an other like terms, so it will be minus 2x and minus 3. So this is the simplified version of this one. So even if you can leave your answer here, it would be still correct. So it will be up to the examiner if he wants you or she wants you to simplify completely. So let's do another one. Let me have some space here by dividing. So this time the function is y, which is equals to x squared plus 1 into x plus 5 plus 1 over x. Go ahead and try to attempt this one. Find the first derivative. So always we're going to say that let k of x equals to y. So now we know that k of x is equals to y. And the byproduct rule says, this one says k prime of x is equals to g of x times f prime of x plus f of x times g prime of x. So now we're going to say let g prime of x equals to x squared plus 1 and f of x to be equals to x plus 5 plus 1 over x. So g prime of x will be equals to x squared, the derivative of x squared plus 1 is 2x. And the derivative of f prime of x will be equals to 1 plus the derivative of 5 is 0. How about the derivative of 1 over x? 1 over x can be written as x to the power minus 1. So now apply the power rule here, which says n, this one will become y prime, which is equals to, drop -1 here, then it will be minus 1 minus 1. So it will become minus 1 over x squared. So this one will be minus 1 over x squared. So the y prime here is equals to g of x is equals to x squared plus 1. And f prime of x is equals to 1 minus 1 over x squared plus f of x, which is equals to x plus 5 plus 1 over x times g prime of x, which is equals to 2x. So this is the first derivative for this function here. So this one erase for you. Let's say this time you are given the function f of x to be equals to minus cosec, and the angle is 3x squared, times the cotangent of 3x squared. No, it should be the arctangent of, the tangent of the arctangent of 5x. Go ahead and try to find the derivative of this one. So the product rule in our case will no longer have f. We'll use another one. So now let's use r. So r of x will be equals to g of x times, let's say, q prime of x plus q of x times g prime of x. So now let this one to be g of x. Here this one is positive. So we'll have cosec 3 x squared, and the q of x will be equals to the arctangent of 5x. So g prime of x is equals to the derivative of cosec is equals to minus cosec 3x squared times the cotangent of 3x squared times the derivative of the angle. So the derivative of the angle is 6x. And the derivative of q prime of x, of q of x, will be equals to the derivative of arctangent of 5x is equals to 1 over 1 plus 5x all squared. And the derivative of the angle is times 5. So this is equals to 5 over 1 plus 25 all squared. X squared. So now we have all the function here. So now it's time for us to substitute. So f of x will be equals to f prime of x will be equals to g of x is equals to cosec 3x squared, and q prime of x is equals to 5 over 1 plus 25 all squared plus the derivative of, plus q of x, which is equals to the arctangent of 5x times the derivative of j prime of x is equals to what's written here. So we'll have minus 6x into cosec 3x squared times the cotangent of 3x squared. So this line which is here is the derivative of this function. Hopefully now you get it. Let's try another one. And this one should be the last one. Let's say this time you are given y is equals to sine 2t into t to the power 3 over 2 plus 90 plus 8. So here we're going to say let g of x equals to sine 2t and let f of x to be equals to t to the power 3 over 2 plus 90 plus 8. And by product rule, y prime of t is equals to g of x times f prime of x plus f prime of x times g prime of x. So now let's have g prime of x and f prime of x. So I'm gonna take this side. So g prime of x is equals to the derivative of sine is cosine of 2t times the derivative of the angle, which is 2. And f prime of x is equals to, here we're going to apply the power rule. So it's going to be negative 3 over 2 t to the power negative 3 over 2 minus 1 plus the derivative of 90, which is just 9. And the derivative of 8 is 0. So now let's write this well. So we'll have 3 over 2. So minus 3 over 2 minus 1 is equals to. So here we'll have 2 over 2. Minus 3 over 2 is minus 5 over 2. So t is minus 5 over 2 plus 9. So now we have the derivatives. It's time for us to substitute. Let me just push it up. So the derivative of this y of t is equals to y prime of t is equals to g prime of x times f prime of x g of x times f prime of x plus g of x times, g prime of x times f of x. So let's substitute. G prime of x is equals to 2 times cos 2t, and f prime of x, which is here, is equals to minus 3 over 2 t to the power, no, should not be like that, g prime of x is equals to sine 2t, which is here, and f prime of x is equals to minus 3 over 2 t to the power 5 over 2 plus 9 plus g prime of x, which is 2 cos 2t multiplied by f of x, which is t to the power 3 over 2 plus 9t plus 8. And this is the first derivative. If you have not yet subscribed to the channel, please subscribe. And if the video was so helpful to you, you can click the like button for more updates. And thank you very much for taking your time and watch this video.